probability of some event. This is how we generally write this out. Capital P stands for probability. Throw it in parentheses is what you're looking to accomplish. When you're dealing with probabilities, think of it as it's always going to be a ratio, a fraction, a decimal, percentage, something along those lines, of your favorable outcome divided by total possible outcomes. And this is where, when we get into it in terms of just pure math, I think a really easy one that everybody would understand is, what is the probability of rolling a 3 on a 6-sided die? How many possible ways can you roll a 3 on a die?
3. Oh wait, no. How much? Wait, what was the question?
Don't roll dice within the cheats. How many possible ways can you roll a 3 on a single die? 1. How many possible outcomes are there on a die? 6. So there's one way you can roll a 3. That's if you roll a 3 out of 6 possible outcomes. Okay. Now, also goes into the same idea as you start to, if you compound them a little bit. Any of you guys ever played Monopoly?
Yeah, it's so long.
It takes forever to get through that, but do you know why there's certain values, certain things that you should purchase? You should try to purchase everything that's 7 steps, like every 7th thing. Because what's the most common number you can roll when you're rolling 2 die? 7. If you think about it, if we're talking about rolling 2 die, and want to roll a 7, possible outcomes for rolling a 7 is first die is a 1, second die is a 6. You go, let's see, we can count this out here. We have a 1 and a 6, 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, 6 and a 1. So there's 6 possible outcomes out of that, okay? As you go through it. Did I skip one?
No.
Well, there's no 7. So that would be the most common, all right? And that's as you get into these things. That's why certain values of 12 are worth more than other things. It's kind of the same idea. You ever seen a roulette wheel? A roulette wheel, when you have a roulette wheel, it's broken into, oh man, I honestly, a lot. Oop.
Wow.
I don't know what's happening to that.
It's a bunch of, a roulette wheel is a bunch of sectors, is what it is. A roulette wheel is a bunch of sectors. Not really. It's kind of, but instead of being Wheel of Fortune, you've got, you know how on Wheel of Fortune you've got the money spots and you got the bankrupt, you can win a trip and all that. It's kind of the same basic principle, but when you're dealing with roulette, you have even and odd numbers, 1 through, I want to say 36. And then you have zeros. You have a single 0 and a double 0, if I'm not mistaken. So I think there's a total of, was it 1 through 34 and 36 is the, anyway, let's just say there's 36 possible outcomes, and then you have certain values accordingly if you land on a number versus a double 0 versus a square and all that stuff. And it's all predicated upon probability. The lower the probability of an outcome, the higher reward it is when you game. It's kind of what it does. Yes, sir?
So the Russians play roulette with a gun?
Anyway, so what we're talking about, this whole idea of probability of some event. All right. All right, guys. The probability of an event is always within a specific range. It will always be less than 1, but greater than 0. Okay. Probabilities will never have you'll never have a probability that's greater than 1. You'll never have a probability that's less than 0. If your probability of some event equals 1, then it means it's certain going to happen. It's a certainty, or it's going to happen. That's, I don't know, it is today. All right. So probability, if your probability is 1, means it's going to happen. So the probability of having homework is 1.
Because it's one at one time.
It just means what it means is that it's a certainty. So the probability of something happening is going to happen means you're going to have homework.
Oh, okay.
The probability of some event equaling 0, that means it's not going to happen. Like the probability of it snowing outside our school today.
It's a possibility.
You do live in
It's a possibility.
All right.
A couple years ago, it's all day.
Probably like 1 out of a billion.
All right, how about this? The probability of not having homework. 0. Okay, we'll go back to that one.
I
We
can
know-
test.
All right. Now, probabilities are one of those things that you probably saw a very small amount of it before in regular algebra classes. They probably talk about probability of certain events happening, like compounding events. What we get into in geometry is we talk about what's called the probability of what's geometric probability. And that is basically landing in shaded regions. Now there are many different probabilities that you can do algebraically that we go through. One of which would be in algebra. You can talk about probability of landing within certain line segments with mx plus b. You can talk about probability of, as it gets in more and more, of how you can get different card hands, whether it's 2-pair, a full house, things like that. How do you know what you have in terms of the possibility of something else turning over? For example, you guys know that there's 52 cards in a deck, right?
Yeah.
Okay. Now, the probability of getting, let's see, 4 aces, the probability of being dealt 4 aces. Well, how many aces are in a deck? 4 of them. So if I flip over a card, probability of that one card being an ace is 1 out of how many? 52. So that's for the first outcome. How many, if I don't put that card back in the deck, how many are left? 51. What's the probability of getting an ace?
1 out of 3.
1 out of 51.
Sorry.
And then it'd be 1 out of 50, and then 1 out of 49.
Yeah.
What happens here is you multiply all those things together, the probability of actually getting 4 aces in being dealt to you is pretty slim to none. Okay.
We're talking about in a row.
You can do it in a row, or just probably getting 4 cards that are aces. There's a lot of different things that we can do with this vocabulary-wise to show how different things can occur.
What
So-
would be 4 out of 52?
That just means what happens is if you're doing the 4 out of 52, yes, there are 4 of them out of 52. That's the probability of just getting 1 card being an ace. But I want it. Actually, you know what? It should have been that. Now I'm saying this out loud. There's 4, so you have a possibility of 4. Then it would be 3 left, and then 2 left. So, but guys, you don't have to write this part down. I'm just trying to show you how there's all these different things here. We're not going to do this in geometry. This is just. But yeah, as soon as you said, I'm like, oh wait, that's right. It's going down that way. Same thing as lottery. Powerball. There's 52, I think, 54 ping pong balls in there.
Yeah.
And each number doesn't get replaced, so there's the probability that you pick actually all 6 numbers. You get the first one right out of the 52, you get the next one right out of the 51, you get the next one right out of the 50, the next one right out of the 49, the next one right out of the 48, and then the Powerball number is the separate one. There's another 52 of them. So basically, when you multiply all that out, it's a giant number that means you're just throwing away money. But I know somebody has to win somewhere along the lines. But it's the idea that what we try to do in Algebra 2, different from this class, is to show you guys numbers. There's so many different things you can do with them just to help kind of see the world as big as it really is. And numbers do that because numbers get so large so fast without you even realizing it. If you really go down and think about it. Okay? But like I was saying, what we're going to spend our time on is things like this, where we take, oops, one button. Sorry, I tried to fill this in real quick. Probability of a shaded region. What's the probability of picking a point that lies within the shaded region? That's the kind of stuff that we do in geometry. Which means you're working with areas. And you're just working with areas on more than one occasion. Now, what we're going to look at in here is same thing you've done. How do you find the area of the shaded region? Well, what's the shaded region here? It's a rectangle with something cut out of it, another rectangle cut out of it, isn't it? So you know how to find the area of a shaded region. So let's say this is 20 by 8, and this is 16 by 6. I'm just making up numbers. So to get the area of the shaded region, what we're looking at for this probability, the way that we find this would be the favorable area divided by total area. Favorable in this case is the shaded region. Okay. The shaded region is made by a rectangle with a rectangle cut out of it. How do you find the area of a rectangle? Base times height. So in this case, it would be a 20 by 8 subtract a 16 by 6. Total area. What's the biggest shape? The 20 by 8. And that's what we're doing. Okay? And that's what we're doing. As you go through this, you can type in basically this, 20 by 8, subtract parentheses, 16 by 6, and I get that for a numerator. 64 over 160. That would be, and when I divide that out, it gives me an answer, 0.4. Your calculator might say 2/5. Is either one of those wrong? Is either one of them right? It just means the exact same thing. So what you're doing here is you're just finding the area of the shaded region like you would normally, and then you just divide it by the biggest shape that you have.
That's it.
That's it. Okay. And it's built on just knowing how to find areas of shaded regions. So, like I said, these last two sections really, was it 11.6 and 11.7, they're all kind of the same, where you're just finding areas of shaded regions. Okay. Does it always say just rectangles though? Let's try to get this one. This one didn't show up as clean. Let me shut this one off so you can see it better. What we have there is a circle inside of a square. And I want to see what's the probability of landing in the circle. Now, I know it didn't show up as cleanly as I had hoped, but imagine, if you will, all the edges of the circle touches the square. So it is inside that square. What's the probability I hit the circle? That's what I mean. Or land in the circle, or pick a point that lies within the circle, something along those lines. Well, what's your favorable area? The circle. What's the big shape then? So basically I have to find the area of a circle and divide it by the area of a square. Well, the area of a circle is pi r squared, but I'm given a diameter.
So just cut it in half.
Right, so what's half of 12?
6.
6. So if the radius of the circle is 6, what's its area? 36.5. And then I divide that by, very good. And again, your calculator will spit it out a little bit differently. It'll probably say pi over 4. It says, your calculator, because of the way that it simplifies with pi in it, it'll say pi over 4. Do you remember what button to press to get a decimal?
Yeah. That's
The double arrow. What is it?
0.7.
0.79.
How do we get 36?
6 squared. Right, if the diameter is 12, that means the radius is 6.
Okay.
We just talked ourselves through it. We didn't actually write it down. That's fine. And that's what we did. All right? You're just figuring as you're going through, how do you set it up? It's area of the shaded region or area of a favorable spot versus the other. Now, I could also say, what's the probability of not in the circle? What do you mean?
Like, instead of doing the area of the circle divided by the area of the square, you would just say
So I would do the area of the square over the area of
It
the
would just be
circle?
zero.
Is what you're saying?
Zero.
Now, if I did the area of the square divided by the area of the circle, if I want to land just in the square, think of it as the blue section. I'm sorry this color didn't show up better. What would I do?
You would do the area of the square minus the area of the circle over the area of the circle.
Big picture. Square, yes. Yeah, if I wanted to find out just the area that's cut out by the circle, it would be square minus circle over square. Or, yes, sir,
Or why don't you just do like 79 and stuff?
other way around.
That's like 1 minus.
Exactly.
That's like
Because this is the shortcut. What's the probability we land somewhere in this entire object?
100%.
100%.
Yeah.
79% of it is inside the circle. What's on the other side of it? 21%. Now, could you have done it either way? Absolutely. Would it have worked if I would have done area of the square, subtract the area of the circle over the area of the square? Yes, you'll get that. You'll still get 0.21. What you use is called a complement. Not to say that you look nice or anything, but it's when you have probability of an event, you have the probability of the event occurring, and then you have the probability of the event not occurring. So if you think about it, the probability of flipping a coin and getting heads is 50%. Well, what's the probability of flipping a coin and getting the tails? 50%. If I take a single-sided die and I want to roll a 3, the probability of rolling a 3 is 1 out of 6. The probability of not rolling a 3 would be 5 out of 6. Because the probability of the event occurring and then the probability of the event not occurring, you put them together, it always has to equal the event occurred. That's kind of how it works. All right? So we don't talk too much about that, but that's one way you can do it. Okay? Min? Okay. All right.
Whoa, Mr. Mark, come on now.
How many circles is that?
But-
1,
But I want to talk about this one a little bit differently.
1, 2, 3.
I want to say, what's the probability of landing in one of the red circles?
There's only one red circle.
All right, red rings.
There's only 3 out
Ah, not 3 out of 6. I mean, but use those numbers in terms of dimensions.
Oh my gosh.
Hey, here.
No. Would you hit the side of that?
Who idea was this? Mr. Murphy? Mr. Murphy,
What's
who
up?
idea was this?
You
This girl. You are
You missed
horrible.
it.
Negative 3.
I'm just kidding.
Why don't you stand right there?
Yeah, go stand there. Go stand there.
Right here.
It might just stick right here.
So that's.
I will be impressed to see you
But remember, it's not 1 out of 3. Yes, I hear you saying that there's rings there, but use them in terms of dimensions. Think of it in terms of 3 inches, 1 inch, 2 inch. Each one of those has a certain width. So we have to figure out areas.
The pressure's on you because we're not impressed until you hit the bullseye.
Hey, go up like about 2, 3, maybe 7.
Now, I will say that when I first, not gonna lie, this has been around for a while. I've been using this for a few years. Have you guys, when you guys were at the middle schools, they had the older style smart boards. You guys ever go up and touch one of them?
Yeah.
There's a little bit of a pressure to it. Like if you take your thumb, you know, press on the side, it kind of, you could feel to it. The older style smart boards had that built into it, whereas these are just a board. Okay. The older ones had pressure, like a little air pocket in it, so that way it knew where things were being touched. This worked great on that. This one's a little bit tougher to make it work because of the cameras. It's looking for it, the object itself gets to it too quickly. So if I actually would have it would have worked, but I haven't quite figured out. It doesn't.
Well, I guess you were fortunate enough to be able to.
So think about it. Probability of landing in one of the reddish circles. I guess they're not orange, red, orange, whatever. I said orange earlier, and then the class was like, oh no, those are red.
Is it red or is it actually? Is it orange or is it scarlet?
Maroon. Anyway.
It's 7 out of 12.
Is it blue?
Now, hold on. It's not 7 out of 12 because you're talking about areas. So you have to find the area of each of these rings. Okay? And that's then we divide that by the total area. So as you go through this, think about it. They're all circles. Okay?
Is it 12?
3, 4, 6, 7, 9.
Oh.
The farthest one has a radius of 9, and then I have to subtract
Wait, how do you get 9?
3, 4, 6, 7,
Oh,
9.
you stopped at.
Because I'm trying to find my favorable region is that
I
red.
was going all the way out to the green.
No, we would divide out, you're right, by 12 pi, or 12 squared pi. So when you go through this, that outer ring had a radius of 9. You have to subtract then this chunk, which is 3, 4, 6, 7, 7 squared. What's that? I'm finding just this ring. Okay, I'm just finding this ring, then I have to find this ring, then I have to find that ring. I have to find all of those independently of one another.
I don't know
Okay.
what
81 minus 49.
Oh.
Use your calculator.
31.
32, excuse me.
And a half.
Okay, so that first one has that outer ring has that. The next one, 3, 4, 6.
Oh, the red. The red is
6 pi. Subtract 4 pi. Excuse me, 4 squared pi.
Oh, I'm getting
But the red is
36 minus 16.
What? What's that weird little thing?
What
By
little?
the 2. What does that say?
How?
32
Equals-
pi.
Tori, 3
Oh,
plus 2 plus 2
it
equals
doesn't
7.
look connected.
The red.
You have to find this has an area of 32 pi. This one had an area of 20 pi. And this had an area of 9 pi. So the favorable region would be all three of those areas added up. What's 32 and 20? 52 and 9. So we have 61 pi over, and like we were saying earlier, 3, 4, 6, 7, 9, 12. The whole thing has a radius of 12, which means it has an area of 144 pi.
Good job, guys.
And then you throw it in your calculator with the fraction bar. And it tells you what your probability
And
is.
then you hit it with the double arrow.
I don't know what you got.
0.42.
I got 0.42.
So the probability of landing in the red would be 0.42. What would be the probability of landing in the green?
0.58.
0.58. It's just the opposite. Because if I land on the circle, it's still going to get 1. Granted, I get the circle. In a perfect world, I get You all right there?
Is
degree,
There are no degrees.
no, the degree.
What?
You don't have to have it in degrees for this one. When you're dividing out, that doesn't matter. Only time you have to worry about degrees versus radians if you're pressing the button that says sine or cosine or change it. That's the only time you have to worry about. But also it allows you to do. Where's the other? Let's find the area of the shaded, or probability of landing in the shaded region again. And now you just have multiple shapes to worry about. Same basic idea. How does the shaded, what's the area of that shaded region? And what's the area of the total object? It's kind of what you're asking yourself to do.
Each of those sides are two. Bottom triangle base, would they be two?
Well, hold on. Let's let everybody get going here. What is, if we're looking at it, there's a couple of ways that you can think about this. Three, yeah. There's a couple of ways you can think about this. The large shape is pretty easy. It's a trapezoid. Okay? It's an isosceles trapezoid, actually, because of the two tick marks on the sides. The interior part was cut out by a rectangle. Right? So you can get your areas a couple of different ways. One of the ways is to do area of a trapezoid, subtract the area of the rectangle, divide that by the area of the trapezoid.
I think I propose.
That was one of the ways that you could do that. Now, the other way is, if you see this, the shaded region, isn't that just going to be an isosceles triangle? It's going to be an isosceles triangle because if you bring this down, that's 14 here, which gives you 3 for this side and 3 for that side. So don't you just have the area of a triangle divided by the area of a trapezoid is the other way to do it? Does it matter which one you choose?
No.
No. It's just there. You can use either one of them, especially if you're able to figure out that you've got a different type of a shape, okay? And go from there. So I'll use the triangle one. Triangle is easy. 1/2 base times height. Trapezoid, 1/2 the height, sum of the bases. Well, the base and height for the triangle would be 12 and 6. You okay with that? You got 12 and 6 there. Then the other one you have
Big G's coming down with you.
yes, sir.
Because you're
You
so.
have, if you see how you have 14 here? That leaves a total of, we subtract that out, it leaves you 6. Since you've got the two since these are both like that.
So you combine them together.
I'm just putting them together. I'm creating an isosceles triangle out of it. That's all I'm doing.
Or you can just you also like do 3 times 14. Oh wait, no, 3 times 12.
You'd have to, and double it.
Yeah.
It would work the same. Because there's 2 of them. So just start piecemealing it together. Don't try and throw it all in there at once. Believe me, you'll probably screw something up. But write down what you're doing before you do it. 36 over, I don't know what 6 times 34 is, but it ends in 4. Is it 204, I think? over 102, 9 over 51. 9 over 51?
That's yours, that's just a
9 over 51, which is 3 over 17. I don't know what that decimal is. Was it 0.04 or something like that? It's a matter of pressing the buttons in the calculator.
0.17.
I'll do it at the end.
Oh,
Okay. Try another one. Probability of landing in the shaded region. You've done this problem before. You found the area of the shaded region. All I'm doing now is asking you to do one extra step by dividing out by the large area.
What's the 3 telling us?
The height,
Of the square?
well, it'd be a rectangle because the other side's 4.
Or sorry. Okay.
Now, guys, enough. Yes, sir.
How would you figure out the area of a circle if the radius is 1?
Yeah, the radius is 1.
Well, we know that that whole thing going across has to be 4. These still be the same, so it gives you diameters of 2s, which means you have radius of 1, okay? So the area, start thinking about the shaded region was created by the rectangle, which is 3 by 4, and then you have to subtract out 2 circles. The circles have a radius of 1. What's 1 squared? 1. What's 1 times pi? 1 pi. 2 times 1 pi would be 2 pi. And then you divide that by 3 by 4. So calculator, fraction bar. 12 minus 2 pi over 12. 0.48. And it's the idea that you're just putting it together. Don't try to use the division button, because a lot of times if you have stuff in the denominator that you have multiple parts to, you'll screw something up. That fraction bar takes care of that. Okay? The fraction bar alleviates a lot of the worriness of one of these setups. Right?
That started in 5th grade.
Okay. This is about as goofy as some of these things can get. Yes, sir.
Let me draw this.
You guys are supposed to read. You're on that list. All right. This is the snow cone problem. This is the snow cone problem that we did last week. Remember, the snow cone problem is the sector subtracted out the, what is it called, triangle. Okay. So now when you start thinking about it, what you want to do is list out how do you get the shaded region. Well, the shaded region is the area of a sector, subtract the area of the triangle. The big shape here then is a circle. So you're going to want to find all these parts separately. So now if you look at it, that sector has a central angle of how much?
8.
Central angle. It's 90 degrees, isn't it? Is the right angle. So the sector well, we know it'll be 90 over 360, but we have to figure out the radius. Now, excuse me, let me draw this separately real quick.
Wait, but what is the 8 pointing to?
The height, that's what I was about to say. I'm going to redraw just the triangle real quick. Bless you.
Bless you.
Now, we know that the large triangle is an isosceles right triangle.
Oh, so you do 30, 60, 90.
45. Because we know that it has to be an isosceles right triangle because the sides are radii. And since the central angle is the 90, that gives you your 45s. Which means opposite of 45 is 8. Opposite that 45 would be an 8. Opposite the 90 then would be 8 root 2. What's that? Where? Remember it goes x, x, x root 2. Same deal on the other side. This becomes an 8 here, and this becomes an 8 root 2. So now you know what your radius is. Whenever you're typing in anything with a root and you have to square it, you need to put it in parentheses. Said it many, 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 many times. So our sector, 90 over 360 times, parentheses, 8 root 2 squared. I get 32. Put a pi next to it. So the area of that sector is 32 pi. The whole circle having a radius of 8 root 2, you got to put that back in the calculator. 8 root 2. Square it. Get pi. And now I have to go back to the triangle. I now also know that the triangle has a height of 8 and a base of 16.
So base times height.
1/2 base times height.
I have a question.
Yes, ma'am.
Can you do 48? Like, instead of just putting half, you put minus 4.
I can't do 4 times 8 because if I took half of 8, I can't just take another half of 16. Because you're just multiplying straight across. If it was adding between the two, then you can do that. But since you're multiplying, you just multiply. So what's half of 16? 8. What's 8 times 8? 64. So my whole area, the probability of that shaded region then, fraction bar, and you're just finding these separate areas and just writing them down. 32 pi, subtract 64, that was 8 by 8, over 128 pi. And guys, you can't do this without writing down your steps. You can't do this and miraculously just get decimal answers. It doesn't work that way. Okay? You have to show your work, you have to show what you're typing in the calculator before you type it in the calculator. It is so easy to make a stupid mistake. Hit enter. 0.09. Probability of landing in the shaded region is 90%. I think I have 7 of these.
She's
Oh, yeah, I was just playing.
Do you know about those? Oh my God, I don't.
I'm just scared of
Hey, you guys gonna want to do this on a separate sheet of paper? There is no room to do this on here. Bell's gonna ring in 4 minutes. You can make it.
I did. He said.
You really want to come back and get your stuff?
You're not gonna make it?
He said, I had to get to the curb, but I got stuff to the kid.
Hey! Stop it. Do the work on a separate sheet of paper. If it's not on a separate sheet of paper, it wasn't done. Show your work. If you don't show your work, it wasn't done. Plain and simple. Okay? So how it's going to be for the rest, all of chapter 12 as well. All of chapter 12 is basically writing up areas and putting things together with multiple steps. You have to write out what you're doing in order to figure out what you did. You cannot come up miraculously with answers without showing work, ladies and gentlemen. It doesn't work that well. Okay, just so you know. Through all that, there are other things within this. Pay no attention to any of the other stuff on this worksheet about number lines or equations or any of that other stuff. We're not worried about any of that in this class. You will see that again in algebra 2. Okay?
Maybe this is